Now question 9.8. A beam of light converges at a point P. Now a lens is placed in the path of the convergent beam 12 cm from P. At what point does the beam converge if the lens is, first part, a convex lens having a focal length of 20 cm, and in the second part you have a concave lens of focal length 16 cm. So we have two questions. Let's solve the first one. So just look at the question. A beam of light converges at a point P. That means the beam of light is converging. You can know that this should be the type of the beam. It should be the converging beam. So it's a converging beam. You know that. Usually if you have a real object, you will have a diverging beam. So here it means it would be a virtual object for sure. So let me draw it again. So let's assume this is a beam coming like this, and let's say like this. This is a converging beam meeting at a point P like this. Now a lens is placed 12 cm from P. First case it's a convex lens. So if I place a convex lens, so it's placed here. Now this distance is given as 12 centimeters. So now the rays won't go like this. So let me draw it like an extended way. So this is a virtual object which is P. So first of all, first thing is clear that the object distance as per our convention would be plus 12 centimeter, because the light is going like this. This is the incident direction. The object is into the right of the lens. Okay. At what point does the beam converge if the lens is convex lens? So what you have, U is plus 12, focal length of the lens is plus 20 centimeter. So this is given to you now. So where will it converge now? So we have to find the case of V. So just apply the lens equation, which you write as 1 by V minus 1 by U equals to 1 by F. So you can write it like this, or you can directly, like most of the people remember, you can write it like this, UF upon U plus F. So put it, this is plus 12 into plus 20, 12 plus 20. So what you have, this is 240, this is 32. So if you solve it up, let's say this would be 4 in the table of 8, this would be 30. So 30 by 4 is 7.5 centimeters. So it means the image would now be formed at 7.5. That means somewhere here. So it will be now more converging like this, and this would be the image formation like this. So this would be the image formed in the first case. So for the first case the answer is 7.5 centimeter. Now for the second one you have almost the same case. Let me draw it again. So let me draw it like this. So this is your point P. Now what you have done, you have placed not a convex lens here, you have placed a diverging lens, concave lens like this. Let me again make it extended. So again still the U is going to be plus 12, but here the change would be the focal length is not 16, I'll write it as minus 16 because it is a diverging lens. So again using the same formula, V equals to UF over U plus F. So it is 12 into minus 16, 12 minus 16. So above you get 16 12s are what you will have, that is 160 and 192, and this would be minus 4. So minus minus get cancelled, and it would be, what I can write this, 448. So it would be 48 centimeters. That means definitely it would be more diverging from here. It will be somewhere here like this. This would be the image formation now at 48 centimeters from this lens. If I see this, this would be 48 centimeter. So these are the two parts. The first part answer is 7.5 centimeters, and for the second one it is 48 centimeters.